Okay, I hear the recording in progress, so we'll go ahead and share the screen. All right, so I'm going to do some more problems from 10.6, clean that up, and then we're just going to do some review questions in preparation for the test on Friday. Okay, so I'll do some problems from 3.6, but I'll jump around to some other sections also as needed. Okay, so a quick reminder, exam this coming Friday. You're responsible for this material. You have to submit at least 70% of the homework, but that's pretty easy to do considering I do sometimes up to 70% of the homework already, in which case all you have to do is just copy. All right. And so you've seen exams already. So a little bit after 8 o'clock, I'll send the exam on Canvas announcements. And you join, you'll have your camera on with the true background. Keep yourself muted. If you have any questions during the exam, put it in the chat. I'll close the class at 10 o'clock. Then you have until 10:05 to take pictures on your cell phone, click, 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 click. Or if you have a scanner, scan it, it's a little bit better quality. And then you have until 10:30 to submit the homework. Although I suggest if you already have it done, just submit the homework early, like after class tomorrow. That'll be good enough. Okay. All right, so let me go back and start doing some more problems. Okay, 3.6 problem 13, we alluded to earlier. 3 minus 8i, 2 plus I with a bar. The bar means conjugate. That's a little arrow there. It's conjugate. The conjugate of 2 plus I is 2 minus I. So it's just another way of saying give the conjugate of 3 minus 8i, 2 plus I, or give 3 minus 8i times 2 minus I. That's all. That's all they mean by that extra stuff that they have there. So you just FOIL like usual, except whenever I get an I squared, I have to remember I squared gives me a -1. Okay. So first is 6. Outer is minus 3i. Inner is minus 16i. And last is minus 16i squared. And there's that I squared again. So that's minus 16 times -1. I squared is -1. Put that on your cheat sheet if you wish. And that gives me a plus 16. And then I do the real part first. 6 plus 16 is 22. And then minus 19i. Okay. So 22 minus 19i. All right. Let me check something real quickly. Sorry, I'm going to stop the share. Yeah, I just want to make sure that I was recording. Okay. All right. All right. 27. Simplify 1 over 2 plus 3i. Right. So the trick is to multiply by the conjugate of the denominator. The conjugate, not opposite. Opposite means negative, negative. Conjugate means keep the real part alone, 2, but change the sign of the imaginary part. So 2 minus 3i. 2 minus 3i over 2 minus 3i. I messed up the first time I did it. I put a plus. It's supposed to be a minus. All right. So 1 times 2 minus 3i is just 2 minus 3i. And then the bottom, that looks like a plus b, a minus b, right? 2 plus 3a, 2 minus 3i, which is just a squared minus b squared from algebra. 2 squared is 4 minus 9i squared. If I can get this thing focused here. Try to get this in focus. Oh yeah. So 4 minus 9i squared, and I squared is -1. So it's 4 minus 9 times a minus 1 is 4 plus 9, 13. So I have 2 minus 3i divided by 13. And they just split it into 2. So break it into 2, 2/13 minus 3/13 I. That way I can write it as a real part and an imaginary part. Okay. Okay, moving right along. 47, I want to try to do as much as I can in preparation for the test, of course. That's coming up. 47, find all zeros of the given function. Okay, it's third degree, which tells me there's going to be 3 zeros, and there's going to be 3 factors. Okay, so the hard part is just come up with one solution. Once I have one solution, I can divide out to get a second degree equation. Once I have a second degree equation, I can always rely on the quadratic formula as necessary. Fortunately, it's not too hard to show that 3 works. So how did you get that? Well, I notice how everything here is a multiple of 3, right? 3, 3. So I just said, let me just guess 3. It happens to work because there's a lot of 27s. Okay. Yeah, sometimes you don't know that ahead of time until you try it. So if we put 3, 3 cubed is 27, right? And then minus 3 times 3 times 3, that's 27, so that's 0. Then put a 3 here, 9 times 3 is 27, minus 27, 0. Okay. So f of 3 is 0, which means x minus 3 is going to be a factor. Okay. I know that x minus 3 is going to be a factor of this thing. Okay, so I do the synthetic division because it's easier. 3, remember the 3 here means x minus 3 ends up being a factor. All right, put the coefficients 1, -3, 9, -27, and 3. So right away, if I plug in 3, I get 0. Okay. This algorithm says if I do the synthetic division, my remainder ought to be 0, the factor theorem. And you can see that it is. All right, so here we go. Bring down to 1, and then multiply, add, multiply, add, multiply, add. So 3 times 1 is 3. Add 0. Multiply, 3 times 0 is 0. Add 9. Multiply, 3 times 9 is 27. 0. So now, how do I write my original function? F of x is 1 factor is x minus 3. And how do I read this? X squared plus 0x plus 9, which I'm just going to write as x squared plus 9. And now this is pretty easy to work out. It looks like I'm going to have 2 imaginary solutions. So I'll solve x squared plus 9 equals 0. Subtract 9. X squared equals -9. Do the square root property. Put a plus or minus. So x is plus or minus. Take out the negative I radical 9. Radical 9 is 3, but you don't write I3. Once I don't have the square root anymore, you write it as 3i. Usually, you put the number before the letter. So plus or minus 3i. So there we go. And so going back to where I started from, third degree, right? So the fundamental theorem of algebra says what? There should be 3 factors and 3 zeros if you allow for multiplicity, if we're allowing for the duplication stuff. Okay, and here they are. The 3 zeros are 3 and plus or minus 3i. If we said there's going to be 3 zeros, nobody said they had to be nice. Nobody said they had to be real. They could come out to be complex. So in this case, they are complex. 3 and plus or minus 3i. And there are 3 factors. How do I write the 3 factors? You just go x minus each of these. X minus 3, x minus 3i, and x minus 3i, which is x plus 3i. So here are the 3 factors. Okay, and if you feel like it, if you multiply all of this stuff out and be very careful about the I business, you should get back this. Third degree, so 3 zeros, 3 factors. Okay. All right, then let's see, 49. X to the 4th minus x squared minus 2x plus 2. Fourth degree. Therefore, this should be how many factors? 4. This should be how many roots? 4, if we're allowing for multiplicity. Okay, and again, once we can knock this thing down to second degree, right? If I can get it down to be a second degree, I can use a quadratic formula at worst. Now, I could do the rational zeros theorem. I mean, there wouldn't be that much to try. It'd be a factor of 2 divided by a factor of 1. So it looks like the only things to try are plus or minus 2 and plus or minus 1. I noticed by inspection right away that 1 works. 1 should work. 1 raised to any power is 1. 1 minus 1 is 0. Minus 2 plus 2 is 0. So 1 definitely works. And that tells me x minus 1 is going to be a factor. X minus 1 is a factor of my original polynomial. So here we go. 1, 0. You say, where does that 0 come from? Because I don't have any x cubed. See, once you have x to the 4th, right? You must have x cubed, x squared, x, and number. Anything that's missing counted as a 0 coefficient. So 1 works, which means x minus 1 is going to be a factor. So 1, 0 for x cubed, negative 1 for x squared, negative 2 for x, and 2 for numbers. All right, here we go. 1 comes down. Multiply, 1 times 1 is 1, add. Multiply, 1 times 1 is 1, add 0. Multiply, 1 times 0 is 0, add negative 2. Multiply, 1 times negative 2 is negative 2, add 0. Remainder is 0, just as I anticipated. Okay, now I'm going to show you something new, which might save some time. Yes, this is x cubed plus x squared minus 2. This really means this, right? X cubed plus x squared plus 0x minus 2. Okay. But I noticed for this depressed equation, 1 still works. If I plug in 1, it works, right? 1 plus 1 minus 2. So rather than starting to write all over again, you can just immediately synthetically divide from here. See how I put the 1 right away? I already knew that 1 was going to work again. So how did you know that? I just plugged it in. This represents x cubed plus x squared plus no x minus 2. So I looked at this and say, hey, 1 works again. So I'm going to have 1 of multiplicity 2 minimum. It might work again, but at least it's going to happen twice. So rather than rewriting it all over again, just synthetically divide, ignore that you already did all this. I mean, if all you saw was this, right, you would just say, oh yeah, that's fine. Okay, so here we go. 1 times 1 is 1, add 2. 1 times 2 is 2, add 2. 1 times 2 is 2, add 0. It works. So now I have 2 factors of x minus 1 squared. And then how do I read this? X squared plus 2x plus 2, which is not factorable, but I can use a quadratic formula. So that's usually the name of the game for these kind of problems, right? Factor as far as you can go. Once you get the polynomial depressed down to second degree, then quadratic formula to the rescue at worst. All right, so A is 1, B is 2, C is negative 2. X is negative B, negative 2, plus or minus the square root of B squared, 4, minus 4 times A, which is 1, times C, which is 2, over 2 times 1. So this is going to be 4 minus 8, which is a negative 4. So that tells me I'm going to have complex solutions, right? I business. So take out the negative, make it stand up as an I. Negative 2 plus or minus I radical 4. Radical 4 is 2. So negative 2 plus or minus 2I over 2. Cancel 2 here, cancel 2 here. So negative 1 plus or minus I. And we're ready to go. Okay, so from the get-go, 4th degree, which means how many zeros? 4, if we allow for multiplicity. And how many factors? 4 if we allow for multiplicity. In this case, we do have multiplicity. So my zeros are 1 of multiplicity 2, -1 plus or minus I. That's 4. There's 1, another 1, -1 minus I, and -1 plus I. Okay, so again, from the start, if we have real coefficients like this, you will have 4 factors and 4 zeros. Nobody said they were going to be nice. They didn't have to be real. Okay? But if we allow for complex numbers, right? If we go into the I business, there's going to be 4. Here are the 4. And how do I write the factors? Well, this one I think you can understand. X minus 1 squared. This is kind of messier, but no matter what it is, maybe just cover it up. I'm going to go X minus that. So X minus parentheses, -1 minus I, and then X minus parentheses, -1 plus I. Okay. You could keep going farther if you wanted to, but let's just leave it like that. Okay, 53 is a build a polynomial, make up a polynomial, right? So 53, degree 4, zeros are radical 3i and 3i. So remember, we have a rule that says solutions come in conjugate pairs. Conjugate pairs of real polynomials on page 183. If you have a complex 0 z, its complex conjugate z bar is also a 0. So if you have 3 minus 4i, and you know it works, then 3 plus 4i automatically works. Again, that stands to reason from the quadratic formula, right? Since they tend to be paired. They tend to be paired because you plug in the quadratic formula, right? The quadratic formula has a built-in plus or minus. So if this came out to be, 2i, then the plus or minus tells you automatically have the negative 2i, etc. All right, so 53, determine 4th degree, 2 zeros are radical 3i and 3i. So that automatically means I get the conjugates. So the conjugate of radical 3i is negative radical 3i. You say, what's the real part? It's 0. So pretend it's 0 plus radical 3i. So I get 0 minus radical 3i. And then the complex conjugate of 3i is negative 3i. Because you can pretend that's 0 plus 3i, 0 minus 3i. So how do I build the polynomial? You go x minus each one of these guys. So x minus radical 3i, x minus a minus or x plus radical 3i, and then x minus 3i, x minus a minus or x plus 3i. Okay. And let's multiply this. It's actually not going to be that bad. Okay, because this is like a minus b, a plus b. This is also a minus b, a plus b. So x squared minus 3i squared. Okay, and that's going to change to plus 3 because it's -3 times -1, I squared being -1, x squared plus 3. Here I'm going to have x squared minus 9i squared. That's -9 times -1, x squared plus 9. So I have x squared plus 3 times x squared plus 9. Then I just FOIL it out. X to the 4th plus 9x squared plus 3x squared is plus 12x squared plus 27. So there's the build a polynomial, as it were. So you see, we're kind of going backwards, right? So before the problems were, here's a 4th degree polynomial, right? Find the 4 zeros and the 4 factors. So here they are. Now we're going backwards. If you have these solutions, what's the polynomial? And we're using the fact that these come in complex conjugates, right? If radical 3i is a solution, negative radical 3i is a solution. And likewise, here 3i and negative 3i. So we're building a polynomial as opposed to start with this, right? Start with this, come up with the zeros and the factors. Now we start with the zeros, come up with the original polynomial. Okay. So that's how that one works. All right. Okay, I may come back to more 3.6, but I do had some requests for going back to some other problems in preparation for the test. So I'm going to jump around now. I'll jump all around the previous sections also. Some of it is review. Let's see. 3.437 had a slant asymptote. So let me review that one. F of x equals x squared over x minus 1. How do I know there's a slant asymptote? So this is second degree, this is first degree. So if the degree of the numerator is exactly one more than the degree of the denominator, I have a slant asymptote. Va, vertical asymptote, x equals 1. And the graph goes through the origin. How do I know? Plug in 0, you get 0. And if y equals 0, x is 0. So the graph goes through the origin, and there are no more intercepts. And then I did synthetic division of x squared plus 0x plus 0, right? X squared plus no x plus 0. And divide by x minus 1 means I put 1 here. This time there's going to be a remainder. So 1, 1, 1, 1, 1, a lot of ones. So how do I read this? X plus 1 plus a remainder of 1, 1 over x minus 1. This will be the asymptote, y equals x plus 1. Because if I plug in n behavior, x is super big, this is 0. This is a super big negative, still approaches 0. So when I go way out to the right or way out to the left, the graph gets really, really close to the SA slant asymptote. Okay, so I have a HA, horizontal asymptote, sometimes, not this problem, a VA, vertical asymptote, and now a SA, I guess, slant asymptote. Yes.
If we were using polylog division to factor for this problem, like it would be like x minus 1 times x plus 1 over x minus 1, right?
Correct.
Okay.
So yeah, you can double check your answer. Since I divided by x minus 1, I take this whole thing and multiply by x minus 1. You should get back the original x squared.
Yeah, okay.
Okay, then my only VA, vertical asymptote, was x equals 1. So I pick something to the left and to the right. So x approaches 1 from the left, 0.99. X approaches 1 from the right, 1.01. Here's the original expression. I notice x squared is always positive, right? So plus plus on top. Okay, 0.99 minus 1, that's definitely negative. So positive divided by negative is a negative. Y approaches negative infinity. X approaches 1 from the right, 1.01. Okay, positive on top. 1.01 minus 1 is a positive. Positive divided by positive, positive. Y approaches infinity. All right, so that clinches it. Goes through the origin, shoots down. Over here, gets close to the slant asymptote. And let's see, on this side, we shoot up toward infinity as we approach 1 from the right. So it shoots up like that, and then go toward the slant asymptote. Okay. And there we go. And you say, how do I know where this point is? We don't. Okay. You'll learn techniques in calculus, how to find that turning point. Okay. Well, here it looks like it's going to be the origin. But where is this? Right now, we don't know how to do it. I have to wait for calculus for that. Okay, 3.643. Okay, so you're given one solution is 3i. So that automatically means negative 3i also works. Okay. So in this case, So again, they tell me x equals 3i is a 0. X equals negative 3i is also a 0. So I have as factors x plus 3i and x minus 3i. Multiply that out. X squared minus 9i squared. And again, there's a recurring theme, negative 9 times negative 1, x squared plus 9. So if I do polynomial long division, I should get no remainder. Okay, so x cubed minus 2x squared plus 9x minus 18 divided by x squared plus 0x plus 9. And again, a side note, this is not first degree, it's second degree. Therefore, I cannot do synthetic division. Synthetic division only works for linear expressions like x plus 3 or x minus 5. But once you get into x squared, got to do long division. All right, so x squared into x cubed, x. Now x times this whole thing, x cubed plus 0x squared plus 9x. Subtract, that cancels out. Negative 2 minus nothing is negative 2x squared. 9x minus 9x is 0, going down to negative 18. Then how do I go from here to here? X squared to negative 2x squared, I multiply by negative 2. Now negative 2 times this whole thing, negative 2x squared plus 0x minus 18. No remainder, just as I anticipated. So the last factor is x minus 2. So it's all done. There's supposed to be how many factors? 3. How many zeros? 3, because it's third degree. So here's the complete factorization. They already told me 3i, which means x minus 3i, and automatically x plus 3i, and the last factor is x minus 2. So here's my factor list. And here are the zeros, 2 and plus or minus 3i. So again, just when we start from the get-go, there's going to be third degree, 3 zeros. Nobody said they'd be nice. Nobody said they have to be real. You could have complex numbers. And likewise, the factors may not be nice, but there's got to be 3 zeros and 3 factors. Okay. All right. Okay, so that takes care of that. And let's see what other things that I want to show for you. Okay, I got a request for 3.2, number 33. $3.233. The cubic polynomial, blah, 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 has a 0 of multiplicity 1 at x equals 2, and a 0 of multiplicity 2 at x equals 1, and p of negative 1 equals 4. Determine p of x and sketch its graph. Okay. So how do I do that? All right, so p of x, this x equals 2 multiplicity 1 tells me I have a factor of x minus 2. This x equals 1 with multiplicity 2 tells me I'm going to have x minus 1 squared. Right? So 2 works. It's a 0. 1 works with multiplicity 2, and there it is. And that does give me a cubic. It's going to be third degree. It's going to be x times x times x. But I may have to put a k in front. In fact, in this case, I have to put a k. See, if I multiply this whole thing by 3 or 2 or negative a million, I'm still going to have zeros of 2 multiplicity 1 and 1 of multiplicity 2. How do I find out the k? That's why I use this information. P of negative 1 equals 4. All right, what that means is that if I plug in negative 1, the answer comes out to be 4. So I plug in 4 for y. Say, where's y? I don't see any y. Y is here. Plug in negative 1 here, and solve for k. All right, so here we go. 4 goes here, k goes here. Negative 1 minus 2 is negative 3. And where'd I get the 4 from? -1 minus 1 is -2. -2 squared is 4. And there we go. So 4 is equal to -12k divided by -12. K is -4/12 or -1/3. Right, so the polynomial is -1/3 times x minus 2, x minus 1 squared. The zeros are 1 and 2. Then I can do end behavior. Plug in a number to the right of 1. You can pick a million. Suppose I plug in a million. Oh, this is already positive, right? The square, guaranteed positive. Plug in a million, that's positive. But a -1/3 makes the whole thing negative. So shoots toward negative infinity. And how about on this side? -1 million. I already know this is going to be positive. -1 million minus 2, negative. Negative times a negative, positive. So this shoots toward positive infinity. Okay. So right now, I have 0 here, 0 here, positive infinity, negative infinity. And then on this side, it's either going to go up or go down. I'll use the fact that zeros with a multiplicity of 1 must cross the x-axis. So 2, x equals 2, has a multiplicity of 1. All right, that means it has to go up. So there's the graph. And notice this one has a multiplicity of 2, so it does not have to cross the x-axis. In fact, it doesn't. So it goes down, comes back up, and then down, and then stays down after that.
What number is this?
3.233.
Okay, thank you.
All right. Let's see what I've got here. Okay, go back to 3.3, number 9. Use the factor theorem to show that x minus c is a factor of p of x, factor blah, blah, blah completely. Okay, take a look at what happens. You have 4th degree. That means it's going to be 4 zeros. They already give me 2 of them. So if I divide synthetically one of them, I'll be down to 3rd degree. Do the other one, it will be depressed down to 2nd degree. And once I get 2nd degree, I can quadratic formula or, factor if possible. Okay. All right, so they tell me -1 works, -3 works. So 2, 3, -12, -7, 6. 2, 3, -12, -7, 6, and c equals -1, which in terms of factors, the factor would be x plus 1. Is that right? That's the way it works. So p of -1 is 0. That means not x minus 1, but x plus 1 will be a factor. See, x plus 1. And likewise, -3 here means x plus 3 is a factor. Okay, bring down 2. Multiply, add, multiply, add, multiply, add. So -1 times 2 is -2. Add 1. -1 plus 1 is -1. Add -12, and a -1 makes -13. Multiply, -1 times -13, 13. Add them up, 6. Multiply, -1 times 6, -6, 0. And yes, I'm anticipating a 0. Since they already tell me these are roots, you must have a 0 here. And notice this shortcut, rather than rewriting it. Yes, I know this now represents 2x cubed plus x squared minus 13x plus 6. Just pretend that I'm starting from here and I'm plugging in -3, and it'll work. By the way, if you're curious, I could have started with -3 and then -1. you get the same answer. So -3, I'm anticipating should have no remainder, and you can see it doesn't. 2 comes down. Multiply, -3 times 2, -6, add, -5. Multiply, -3 times -5 is 15, add 2. -3 times 2 is -6, add 0. Just as we expected. So now the original polynomial, where'd it go? Here it is, now has a factor of x plus 1 from here, x plus 3 from here. And how do I read this? 2x squared minus 5x plus 2. Yeah, quick double check. Okay, it's not going to be x minus 1, because if I plug in -1 to x minus 1, I don't get a 0. But if I plug in -1 here, I get 0, right? Because it'd be -1 plus 1. And similarly, if I plug in -3 here, I do get 0. But if you had put down x minus 3, and if you plug in -3, you would not get 0. You get -3 minus 3, right? That's why there's a sign change. Okay, if I plug in -3, this becomes a 0, which means you will have a 0 of the function. This turns out to be factorable. 2x minus 1, x minus 2. That's easy to check with FOIL. First, 2x squared minus 4x minus 1x is minus 5x, and then plus the 2. Okay, so we have what we want. 4th degree, 4 zeros, and 4 factors. Here they are. X plus 1, x plus 3, 2x minus 1, x minus 2. And the zeros are -1, -3, a little bit of algebra here, but 1/2 and 2. And there we go. Okay. All right, folks, that was as much as I was planning to do today. We still have 10 minutes or more. Okay, so let me stop. So tomorrow, if you have any questions about any section, feel free to come in with that. I'll do my own little review of some problems, but if that runs out, then you can ask me stuff in addition. Okay, so let me stop the share and check the chat. And I don't see anything in the chat. All right, so if anybody wants to ask a question, you may ask me now. Otherwise, we'll call it a day and we'll just pick up from here tomorrow. Okay, so any questions, please? Okay, 3.515. Okay. Let's see what that one's about. Hmm. 3.515. Okay, I'm trying to write the problem down in case you don't see anything. I'll get to it. Okay, 3.515. So I'll start with y equals x to the 1/3, which means cube root of x. Okay, so I already know the cube root function looks something like this. Okay. And then I translate 1 to the right and 1 up. 1 right, 1 up. So here's the point 1, 1. And I try to draw the same graph as I had over here. Okay, so something like that. So the red is y equals x minus 1 to the 1/3 plus 1. All I've done is lift it up and move it to the right 1 unit. Ends up looking something like that. Okay. Okay, and let's see, 3.521. Okay, so I think I already did that one, but I'll approach it from a different view. X at a negative 1/2 plus 2. Oh, minus 2. Sorry. Minus 2. All right, so I'll approach it a little bit differently than what I did before. So I'll start off with my square root function. Then I'll play the reciprocal game. Okay, I'll do that in red. So function is not defined at 0. This increases, so this decreases. If I go this way, this decreases, so this increases. 1 over radical x. And then I shove the whole graph down 2 units. By the way, I do have an asymptote, which is the x-axis. If I move down 2 units, this is 1, negative 1, and I just have the same general shape. So horizontal asymptote, y equals negative 2. Vertical asymptote is x equals 0, which is the same as the y-axis. Intercepts, x is not allowed to be 0. Okay. Let's see, x cannot be 0. Y can be 0. So y equals 0. 0 equals 1 over radical x minus 2. Add 2 to both sides. 2 equals 1 over radical x. Square both sides. Square, square. 4 equals 1 over x. So x is equal to 1/4. So this is 1/4 comma 0. Okay. I'm allowed to just switch these two, which is what I did there. Okay. All right, and let me check the chat again. I think I've caught up with the chat. Okay, anybody else? Anything else, please?
I just had a quick confirmation for 3.6, number 13.
3.613.
Because when I FOILed it out, I got 6 minus 3i minus 16i plus 8i squared.
Okay, and that's not what I had?
No,
I could be wrong.
I didn't see that.
So 3 minus 8i, 2 minus I.
Yeah.
Okay, 6 minus 3i minus 19i. Plus 8i squared.
Yeah, that's what I had.
Okay. Which is 6 minus 19i minus 8.
Mm-hmm.
Or negative 2 minus 19i. And that's not what I had at first?
Maybe it was a different problem, but I just wanted to make sure, and I think I do know that I was right, so I don't remember.
Yeah, this is right. I may have done it wrong. That
Okay.
happens.
No worries. Thank you.
Okay, all right. And unfortunately, I got to keep bouncing back and forth. I can't see the chat while screen share. Okay, all right, I think I've caught up again. Okay, any other questions, please? Okay, then I guess that'll do it for today. All right, so we'll see you next time. Okay,
Thank you.
right, see ya. Okay, all right, bye. See you next time.